Good morning, students. Today I am going to tell you how to write the electronic configuration of any element. As we know, electronic configuration is very important skill for studying chemistry. Whether it is organic chemistry or it is inorganic chemistry, it is very important that we know this skill, how to write the electronic configuration. We have the AUFBAU principle, but it seems it's little difficult for students to follow that rule. But today I am going to discuss is very intelligent trick with which we can write any element's electronic configuration. So let's see what is the method which I am going to tell you today. So this is very easy thing which we are going to write here. You can see the pattern here. This is SS, PS, PS, DPS, DPS, FDPS, FDPS. If we see it in a very important way, we can see this is what it is written is basically SPDF. We know that the first orbital which is of lowest energy is S, and after that what comes is the P, and after P which orbital comes? It is D, and after D we have F. So basically what we are writing here, we are writing two times S, S, and see here, after S, what I have written here? P, here also see, after S, we have P. So two times we have written PS. Now you can see here, what we have written here, SPD. And again the same thing, the way we have written earlier, this is SPD. See here what we are going to do, SPDF. And here also SPDF. Every time we are writing two times the same thing. Even we can write G after F, we can write G, F, D, P, S. But if we are going to go in that, we are going to go more beyond what periodic table is currently made up of. So I don't think we need to go till that point. We will only discuss till FDPS. So now what more we need to write the electronic configuration? We should see that in first orbital, in the first shell we have only one orbital, that is S. In second shell what we have? We have two orbitals, that is S and P. And what happens in third? We have extra orbital, that is S, P and D. For fourth, what we have? We have S, P, D and F. Now we need to know how many electrons we can fill in each orbital. In S we can fill 2 electrons, in P we can fill 6 electrons, and in D how many electrons? You can see the pattern here also. After 2, what is the common difference? 4. So in D how many will have? 10. In F how many electrons we will have? 14. If we are going to consider about G, it will be 18 electrons. So now I am going to tell you how to give the numbers here. So the number will start from first 1s. 1s is already been filled. Then which s we will take? 2s. Now you see P has not come in first. So from where we are going to write for the P? See here, in the second cell only we have P orbital. So we will write 2P. After 2 which integer comes? 3. See here, 2P is already done. Then which P should come? 3. So in 3 is here, and after 3 what comes? It's very easy. After 3 we have only 4. See here, D. When D has come first time? It has come in the third shell. So we will write here 3D, 4, 5. This is so simple. Now come here, after 3D what we are going to write? 4D, 5P, 6S. See here F, 4. So after 4 it is very fast, we can write it very fast. 4, 5, 6, 7. After 4 what will come? 5F. What will come after 5? 6, 7 and 8. Let's now fill the electrons. So So what we will write here? 1s2 because 2 electrons are there. In s2, in p how many electrons? 6. In s2, in p how many? 6. In s how much? 2. See here, in d how many electrons? 10 electrons. We have to remember that in d there will be 10 electrons. So see, I am putting here 10. In p, see how many electrons I have put in p? These will be 6. In S, how many electrons? 2. Again in D, how many electrons? 10, 6, 2. I think everyone remembers now. See here in F, this is the first time F is coming. So how many electrons? 14 electrons. D already we have put in there. 10, 6, 2. See here 14. Common difference is how much? 4, 10, 6 and 2. So see, it is very easy to put the numbers also and this pattern also. Now I am going to take one example to make you clear how to write the electronic configuration by using this pattern. So now I am going to tell you how to write the electronic configuration of calcium. Calcium atomic number is 20. So we have to fill 20 electrons in the same way. So see what I am going to write. First it will come 1s2, we can check it from there. 1s2, then 2s2, then 2p6, 3s2, 3p6. So check how many electrons have been filled. 10, 14, 16, 4, 10, 12, 6, 18. How many electrons are left? 2 more. So we will have 4s2. And calcium is S block element. How I came to know that this is S block element? Because the last electron was filled in S orbital. Even I can tell you the oxidation state of calcium is 2 because this is the outermost shell and the 2 electrons can be taken out from here. To see how much information we can get out from the electronic configuration. Let's see. So now I am going to write the electronic configuration of iodine whose atomic number is 53. So we will follow the same procedure. What we will write? S, S, PS, PS, DPS, DPS, DPS. Let's check how many electrons have come here. It is 1s2, after this 2s2, then 2p6, after 2 what comes? 3s, then it will be 3s2, after 3, 3p6, then 4s2, then 3d10, then after 3d what will come? 4p6, then 5s2, then after 3D what we will write? 4D, 4D10, then it will come 5P. Let's check how many electrons we have already filled. So it is, see here, we can add all these electrons. 2 plus 2 is 4, 4 plus 6, 10, then 12, then 18, then 20, 30, 36, 38, 38 plus 10, how much? 48. Then 5 electrons will go here. So it has now become 53. So see here, now what informations we can get from here. See, the last electron has gone into the p orbital. It means this is the, so the last electron has gone into the p orbital. It means it is a p block element. So we can also know this is the 17th group element because 5 plus 12 is 17. So many information we can get from electronic configuration. Even we can tell the hybridization, and with the help of the hybridization we can tell the type of the bonding, the type of the shape. So many informations are there, and if you are expert in writing the electronic configuration, I think no one can stop you becoming the master of chemistry. I think the chemistry will be easy for you. Thank you very much.